look at bearings, and would all of you hold your right or left hand up, straight up like an arrow, straight up. Straight up like an arrow is going to be north, and we always start with north, straight up like an arrow. And then for bearings, we're going to use two methods. The true bearing, which is from north, what angle is it? So if it said 85-degree true bearing, it's going to be swinging down to about here, 85 degrees. That's the true bearing. 210 true bearing, that would be somewhere, oh, this is 90, this is 180. This would be 210, somewhere around here. True bearing. It's just from north, you just sweep around like that. True bearing's easy. The one that's a little tricky is the double one. So we're going to start with a direction, go with a degree, sweep, I call it, in a direction. Okay, so we start with a direction like this one. Start north. So everybody hold your arms up, north. Then it's going to say sweep 70 degrees west. So west is this way. So if I sweep 70 degrees west, this is where I end up. Question? Okay, so this is going to be 70. This is north, so we start going north, and then we sweep 70 degrees west. If it said E here, you'd sweep 70 degrees east. Now the true bearing starts here and goes around here. Well, how many degrees in a whole circle? 360. So if you hack off 60, you'll get 300. Hack off another 10. This will be 290 true bearing. 290 of the true bearing. Let's do an easier one. Way, 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 way easier. North, so we start going north, and then we're going to sweep 20 degrees, not west, but east 20. There you go. So this is 20 in here. So that, what's the true bearing of this one going to be? It's just going to be 20 degrees true bearing, right? Let's try another one. Start west. So we start in the west direction, then we sweep 45 degrees south. So this is going to be 45. Okay, so if that's 45, we went 180 plus 45. Is that 225? True bearing. You try this one. East, 60 degrees north. So if we start east, starts here, and then we go 60 degrees north, we're going to end up here. Now this is 60, so what will this up here from north be? 30, right? So what's the true bearing for this one? 30 degrees true bearing. Okay. And then 85, we said, if it's 85, this is going to start north, 85 sweeping east. And then 210 down here. You could do it many different ways. An easy way is to start south and sweep, what is that, 30? 30 degrees west. But you could go west and 60 degrees south. You could do it a ton of different ways. You okay with bearings? It's good. Now, something even easier, angle of elevation. You're going to take a horizontal position and angle of elevation, horizontal here at the ground, and then we're going to sweep up. Elevation is going up, and declination or depression is horizontal going down. So for this angle here, this angle dropping down, this is the horizontal, this is your angle of depression from up here. This one down here from the horizontal up to the building is going to be your angle of elevation. What do you notice about those two angles, this one and this one? if those are both parallel. They're equal, aren't they? They're equal. Yep. Notice that we are going to have some pretty challenging problems. The iPad is awesome. The iPad is awesome because you can use different colors for your pictures, colors for numbers, colors for angles. It's really super helpful. But when you do a problem like we're going to do, you're going to sketch and label those carefully and big. Make those nice and big. Too small of sketches will get you into trouble. You include your measurements, you box your answers, show your solve. I mean, this sounds real obvious, but please, please, please make those pictures big, label carefully. So if we have a problem like this number 4, find the angle of elevation from a bench to the top of an 80-meter building. So here's 80 meters. Here's the bench. Angle of elevation is going to be from here up. And let's see. Oh, the bench is 105 meters from the building. So we want to find this angle we'll call theta. What do you notice about the angle between the building and the ground? 90. So we can use some trigonometry, trickery here. What relationship is there between opposite and adjacent? Which one is that? Sine, cosine, or tangent? Tangent. Yep. Yep. So you'll use your calculator, and then you're going to go theta is the undoing of tangent, inverse tangent of 80 over 105. Would you do that for me right now in your calculator and tell me what you get? (37.4 degrees). Now, can you go to second angle DMS? Give that to me in degrees, minutes, and seconds. So it's 37 degrees. How many minutes is that? (18). Seems low for 0.4, unless I'm... Is that right? Okay, 14 minutes, 18 minutes, 14 seconds. On a test for me, nearest tenth is good. But I want you to be able to do that. It says from two positions 400 meters apart on a straight road running northerly direction, bearings of a tree are this one and this one. What's the shortest distance from the tree to the road? Again, draw a nice big sketch. There's the tree. Here's the shortest distance. We know that from two positions, this is 400 meters, like that. And then this angle, let's see, from two positions, you have a bearing of a tree north 36 degrees east, 36 degrees so many minutes. So this is going to be north sweeping 36 degrees 40 minutes. And then this position, we're going to be starting east and sweeping down here. So this one is going to be 33 degrees 22 minutes. And then, of course, you could find this angle. All of this you could figure out. Note that these are not, this isn't equal. But we're not going to solve this one, but I just wanted to show you, you can draw these and put numbers on, figure things out. You're in great shape. For homework today, you're going to do this building problem, which you won't have trouble with, the leaning post problem, another building problem, and that's it. 3 problems. And this is going to be due for Thursday.